Hi, everyone, and welcome back. It's Kira Garfolo with Greenville Tech's MAT-155. Today, we're going to talk about section 2.4 from the text, which covers frequency distributions and graphs. So today, we're going to get to talk about one of my favorite things. We're going to talk about statistics. If you recall, my background is in statistics, so this is one of my favorite parts. What do I mean when I say statistics? Really, statistics is just a term for data, such as batting averages, profits for businesses, height, weight, etc. That's common in sports, right? If you hear statistics for a football player, that's what they're talking about, is that data. More commonly to me is the branch of mathematics that's focusing on basically using that data, right? We're going to be analyzing, we're going to be summarizing that data, and then a lot of times we're going to use that data to make predictions or inferences on a larger group of people or individuals. This is really where everything that I love about math comes together. Part of the science of statistics is also a number that we can calculate to summarize sample data. And these are called statistics. They're statistical measures. So we can talk about the mean, the standard deviation, things like that we're going to learn in future sections. Those are also called statistics. So you got to use a little bit of context clues to know exactly what we're talking about when we talk about statistics. But the study of the science part of statistics is important because many business decisions are based on statistical analysis. Okay. You guys may all be thinking, oh, I'll never use statistics. And on some level, you definitely will. In any regard, in any walk of life, you're going to use some statistics to inform you about some decisions. Maybe it's in your job, maybe it's in your real life when you're talking about grocery shopping and bill paying, things like that. You might be looking to save money or otherwise. You can use statistics, whether you realize it or not, to make those decisions. And oftentimes we're going to find that it's not possible, or it would be way too expensive or not practical to get data from an entire population of interest. And what I mean by that is if you wanted to sample, let's say, if you wanted to talk to all students at Greenville Tech, for example, you know all the students at Greenville Tech, you can get a list of them, but imagine trying to actually survey every student at Greenville Tech. It would take a lot of time and a lot of effort, and it just wouldn't be very practical. A lot of them may not want to participate, okay? Instead, you could rely on a smaller subgroup of this population called a sample. So we would use the sample information to make our best guess about what the population may believe. So maybe we'd sample 100 Greenville Tech students and ask how satisfied they were with Blackboard. And we could use what those 100 people said about it to kind of get a feel for what the entire student body at Greenville Tech may think. Now, when we have large amounts of data that we've collected, we're going to look to summarize this data, and we'll talk about a few different ways in our course. But one of the most basic ways is to build something called a frequency distribution. Now, everyone has seen these and used these before, but you may not have called them that, okay? Basically, you're going to organize your values into categories, or sometimes we're going to talk about classes if it's a numerical range of values. And then we're just going to count how many observations fall within that category or class. That's it. That's all there is to a frequency distribution. So let's consider this example. If we want to make a frequency distribution for this data, we can do that. We're just going to simply go past every data point and see how many are in each category. So our first one is 83, and it falls between 80 and less than 90. Notice it's 80 to less than 90 because as soon as you hit 90, you're going to bump up to the next category. So this is going to be 40 to less than 50, which is really 40 to 49 in whole numbers. But if you had decimals, this would actually be 40 up to, 49.99999, so on. So we counted 83. 88 falls in the same category. 65 falls here, and so on. I'm not going to insult your intelligence by taking 5 minutes to do this. I've already done it on my own, so I'm just going to fill in the tallies here. Make sure that you can get what agrees. If we count, there's going to be 4 of these. There's going to be 4 of these. There's going to be 9 of these. there'll be 10 of these, 9 of these also, and 6 of these. Again, pause, make sure that you can count. On your test, I wouldn't give you one with this many numbers. It's way too easy to lose some, and I can test you knowing these without nearly as many numbers, right? So that you don't accidentally miss one. It's a good idea, like I said, to go ahead, like I was doing over here, to go ahead and cross them out so that you know what you've counted and what you haven't. Our frequency is just the number of our tallies. So there are 4 marks here, 4, 9, 10, 4, and 6. That's it. That's a frequency distribution. Now, some more details about frequency distributions. One of the things that we'll ask, and you'll probably be asked on a test, is about the class width. And the class width is the distance between the lower limit of one class to the lower limit of the next class, okay? Think about leapfrog. How far do you have to jump to get from the start point of one class to the start point of the next class? Be very careful here. The number one mistake is to take upper limit minus lower limit for a single class, and that is not going to be correct. So in our earlier example, if we look back here, to get from 40 to 50 or 50 to 60 or 60 to 70, we are jumping 10, okay? So our class width is going to be 10 in our earlier example. It is not going to be 9, it is going to be 10. Now, most of the time, we're going to start with a frequency distribution like that, okay? But then we can also present it graphically. And one of the easiest ways to present numerical data is with what we call a frequency histogram, okay? And in a frequency histogram, we're going to graphically show that frequency distribution. Our horizontal axis, so that straight line across the bottom, is going to be a number line. Think of the x-axis, right, if we're graphing. And each class is shown on the horizontal axis. So you're going to have like bars across each set of class X values. And the height is going to go up to that frequency. This allows us to really easily and visually compare classes. There are a lot of ways to make a histogram, and your histogram may differ from my histogram, and they both maybe be great. But there are some rules that we need to follow so we don't make a bad histogram, okay? Lots of ways to make good histograms, but there are also some ways to make bad histograms. To make a good histogram, you really want to follow these rules. Our classes need to all have the same width so that our bars are equally wide across each other, okay? We don't want to have one that goes from 10 to 15 and the next one goes from 16 to 35. That wouldn't be a fair comparison, okay? We want to have all of the same width classes. Similarly, the scale for our classes has to lie on that horizontal number line, okay? And it needs to follow an equal scale. You want same space between 1 and 2 and 3 as you do 4 and 5 and 6. Again, it's just a standard number line. The frequency, so the scale for how much data we have in each class, should be on that vertical y-axis. The height of our bar should go to that frequency, and it'll be shown at that in the class, okay? These instructions sound a lot trickier than they are, okay? Basically, you're going to be putting a number line, and you're going to draw bars for the values on those number lines as high as you see frequencies in that class. And generally, there should be between 5 and 20 classes. There's a lot of math as to how many classes there should be. I'm not going to ever ask you how many classes here. But just know that in some statistics courses or other, software, it will use some very complex mathematical formulas to decide how many classes there should be. The more data you have, the more easily you can split into more classes. So from our earlier example, if you look back at our frequency histogram or our frequency distribution, we can build this histogram, okay? Remember, from 40 to 50, we had 4. From 50 to less than 60, we had 4. From 60 to less than 70, we had 9. Our next class had 10, 9, and 6, okay? And anything beyond those were zeros. Notice that our scores are down here, and our frequency is on our y-axis. Okay, So let's try one more. Let's make a histogram with this data. So we have a frequency distribution and we want to make a histogram. So we see that our ages go from 21 up to just less than 51. And this is going to be an interesting sketch. I'm not a very good artist. Okay. And so our frequency will be here. And our frequency goes from 50 up to 250. So I'm going to make it be by 50s. So 50, 100, 150, 200, and 250. And again, we go from 21 up to less than 51. So I'll just start at 21. And we're going up by 5. So 21, 26, 31, 36, 41, 46, 51. Okay. Not perfect. They're not perfectly uniform. Obviously, you know, using technology, using graph paper, we'd get it a little prettier. But just to get an idea here. So we have 150 in this first class. So we know that this bar, this bar is going to go up to 150. And again, I'm a terrible artist. Okay. If you're ever unsure, you can always mark it as 150. Okay. 26 to up to 31 goes to 200. So we're going to draw that up to 200. 31 to less than 36 is only 100. So we'll go right here. 36 to less than 41 is 50. So we'll go right here. 41 to 46 is 250. So we need to be careful here. That was terrible. So we'll go right here. And 46 to less than 51 is 100. So it's going to look something like this. Okay. Again, terrible drawing. It's even worse if my handwriting's bad enough, and then trying to do it on the mouse is even worse, but you can kind of get the picture here. Okay. Now, let's talk about answering some questions with histograms. This is going to be more likely what you will see on an online test, right? Because I can't ask you to draw on an online test. So, in this histogram, we see that we have the number of families having given this number of children, okay? So, our frequency here is going to be how many families have this many children, okay? How many families are represented on this chart? Well, we have 10 families that have no kids, 8 families with 1, 9 families with 2, 5 families with 3, and 2 families with 4 and 5 each, okay? So how many families total do we have? Well, we need to add all the frequencies. We have 10 plus 8 plus 9 plus 5 plus 2 plus 2, and that is going to give us 36, okay? So 36 families are represented here. How many of our families have exactly 2 children? Well, exactly 2 means that we're only looking at 2 here. Well, that bar has 9. So we have 9 here. How many families have more than 2 children? Well, here, what numbers are more than 2? We don't count 2 anymore, okay? Because 2 is not more than 2, it's just 2. But now we have to count 3, we have to count 4, and we have to count 5. So how many families do we have? 5 plus 2 plus 2, which is going to also be 9. Now read this one carefully. It's asking a different question than the top one. What's the total number of children in all of these families combined? Well, that is just going to be the number of children times how many families have that number of children. So 10 families have 0 children, so 0 total there. 8 families have 1 child, so there's 8 kids there. 9 families have 2 kids. 5 families have 3. 2 families have 4. And 2 families have 5. If we add all of that up together, We add all of those up together, we are going to get 59. There are 59 total children out of those 36 families. If you need to pause for a moment to digest that, go ahead. Now, in addition to histograms, we can talk about something called a time series plot. And in a time series plot, we have time on that horizontal axis. So time is down here. Our value being measured on the vertical, okay? And we're going to plot points like coordinate pairs, okay? So for this time, we have this value, this time we have this value, and so on, okay? Each point now, it's not just a scatter plot if you've seen those before in other classes. We're actually going to connect each point with a line segment. So in order, we'll connect them, okay? In this type of graph, we get to see the trend over time. So that's the big perk here. We get to actually see what is going on over time. If you're talking about, these are common in businesses, right? So if you're talking about maybe sales per quarter or sales per month, you can see, are the sales going up? Are they going down? Kind of what's going on here. Here's another example of a time series graph. This is actually from one of the instructor's electric bills, okay? So there's 3 different graphs on this same plot. The average home is the blue. The yellow is per specific home, and an efficient home is green. So how much energy usage is going on? And you can kind of see the trend. Fairly low usage December through about May. And then for the summer months, the usage goes up. It doesn't take much to think about why that might be true. What do we use more of in the summer? Our air conditioning. Then the usage plummets for everybody and goes on. Now, so far, everything we've talked about has been numerical data, okay? So we're counting how many things are in each category, and, you know, the classes, how many do we have 5 children or between 5 and 6 children, things like that. But we're not always dealing with counting or measuring something, right? Sometimes we're concerned about non-numerical data, like how many colors we have, of how many colored M&Ms do we have in each bag, how many reds, how many oranges, how many blues, how many students of each major program are in our class. Majors, it's not a numerical variable, right? It's just a major. Maybe you're nursing, welding, things like that. What's the frequency distribution for eye color in our class? Okay, these things are non-numerical. We can still count how many of each we have and then put it in a frequency table, just like before. If we want to represent these with a graph, then we would want to use a bar graph. It's very similar to a histogram, but it is not a histogram, okay? Our horizontal axis now just has the categories listed. It's not a number line because we're not measuring anything. We still have that vertical axis to be the count or the frequency. We want to leave spaces between our bars here. They shouldn't touch. Like a histogram, they touch because the categories back up to each other, but we use space here. Let's look at an example. Candy colors. So maybe these are M&Ms, some other candy, who knows? We have green candies, brown candies, red candies, yellow candies, and blue candies. We can count how many in a bag we have of each. So in this particular bag, we had 15 greens, 10 browns, 5 reds, 8 yellows, and 8 blues. If we want to present that in a bar graph, we would make a chart just like this. Notice there's space between these graphs, between these bars, and that is a lot easier on the eyes. Now there's one more graph for non-numerical data that we talk about in our class, and it is called a pie chart. Sometimes we call it a pie graph, sometimes we see it called a circle graph. Everybody's probably seen these, but whether you've made them or not, I'm not sure. So pie charts are particularly helpful if you're visualizing the percentage of data in each category. Okay, so you're talking about percents in each category. If you're not given these percents, you'd have to calculate these percents. So remember, we've talked about that already. So if you had 100 observations and 16 of them were red, then 16 out of 100 would be 16%. So your slice would be 16% of the circle. If you want to actually make a pie chart from hand without technology, you actually need compasses and protractors because you're going to be measuring angles, things like that. We are not going to be doing that in this class, okay? But you absolutely need to know how to read them. So for example, remember our grades from before. We had 4, 4, 9, 10, 9, and 6. Okay. We can make a pie chart here by looking at the percents of each of those. Okay. If you calculate the percent for them, you'll see that 14% scored an A, 21% a B, 24% a C, and so on with the circle. Notice that looking at the sizes of the slices gives you a quick and easy visualization of how much of the whole made an A, right? Or how much of a whole passed. So let's take a few minutes and practice a little bit of what we have learned. The following data represents the exam scores for students in a math class. We want to use the following classes. So we want to have 40 to less than 50, 50 to less than 60, 60 to less than 70, 70 to less than 80, 80 to less than 90, and 90 to less than 100. Nobody got a perfect score, okay? Now we can tally. So we have an 88, we have a 90, or 90 goes to the next category, so it's not less than 90. We have a 64, an 82, 275, an 89, a 78, an 84, a 70, a 96, a 79, an 86, a 76, a 95, an 85, a 49, a 79, a 75, a 58, a 68, a 56, an 80, and a 74. Okay, so now to make these frequencies, we just count the tallies. So we had 1 here, 2 here, 2 here. We had 9 here, 7 here, and 3 here. That's it. That's our frequency distribution, or our frequency table. If we want to make a frequency histogram for this data, this is a little tricky on the slide. You want to flip back and forth. But we can draw it like this. Again, I am not an artist, and that is fine. So we had scores down here. And our classes started at 40. So we had 40, 50, 60, 70, 80, 90, and 100. And the frequency of them over here, the most we had was 9, or yeah, so we're gonna do 2. I can't even draw a 2 with this mouse. Oh my goodness. 4, 6, 8, and 10. Okay. Put arrows if we want to be specifically correct here. And now we need to draw our bars. So we have 1 here. And again, it's a good idea to label. 2 here. And 2 here. From 70 to 80, we had 9. So somewhere right there, maybe. And then we had 7 in the next category, so somewhere right there. And then we had 3 in the next category. So there's a really rough histogram for our earlier example. So one more example with a histogram. We already have the frequency distribution. We just want to make the histogram. So we can build here. We're going by 4s. So 4, 8, 12, 16, and 20. I did not space those very well. And we're going to go up to 200. So let's do it by 50, 100, 150, and 200. Okay. Good idea to label our axes here. From 4 to less than 8, we had 100. So we're going to draw a bar right there. From 8 to less than 12, we had 125. So we're going to draw the bar there. 12 to less than 16, we had 75. 16 to less than 20, we had 150. So we're going to go up to 150. And 20 to 24, somehow I forgot that. 20 to 24, we had 200. So we're going to go up to 200 here. And that's it. That's our histogram. What is a bar graph? What if we want to make a bar graph for this data? Well, we can have frequency here. We're going up to 10, so we can do 2, 4, 6, 8, 10. And then remember, this isn't a number line anymore on the bottom, okay? This is just eye color. So we just need to list our categories. They can really be in any order. I usually list them in the order that's given. So we have a blue here, a green here, and a brown here. Now remember, we want space between our bars. We want our bars to be roughly the same width. It's easier to do with technology than drawing. I'm sure mine will look like a serial killer drew it, but you'll get the point. So for blue, we're going to go up to 7. For green, we're going to go up to 10. And for brown, we're going to go up to 5. Play 5. And that's it. That's our bar graph. If you want, you can make them fancy and pretty. You can draw in the bars. You can make them different patterns, whatever. But that is the idea. Now let's get some practice interpreting pie graphs. In this circle graph, pie chart, whatever you want to call it, it represents the household budget of the Smith family. And we want to answer these questions about how much they're spending in each category. So what percent of income do they spend on housing? Well, for this, we want to look at the housing slice. 30%. That one's pretty easy and self-explanatory, right? The 30% slice goes to housing. How much did they spend on entertainment? Well, the same thing. Look at the chart. 10% is on entertainment. Now, what if I wanted to ask the percentage of income that was not spent on food or housing? So we see that food is here and housing is here. We don't want to count these, okay? What does everything else add up to be? Well, 15 plus 20 plus 10 is going to give us 45%. So they spend 45% not on food and housing. Everything else goes to food and housing. And lastly, we have one more example. A similar time series plot to what we saw earlier. How do you think the homeowner is doing over time here? This is energy use. So back in September, this must be last year's data, they were up here. And then it went down for a little while. And now back to this September, I guess this is an old one, it's climbing again. So how are they doing? Not great, right? U is this dark blue. So this is the one we're concerned about, okay? How are they doing? Not great. They're using more than average, using more than efficient, and they are higher on a trend. They're trending upwards, right? And again, you could maybe make the argument like, okay, well, there's, summer or whatever. But you can get an idea for the trend overall. A lot of times, like I said before, you'll see these in things like, sales by quarter, or if you're a stock person, all those stock charts are usually going to be line graphs also, or time series plot. Okay, so in conclusion, graphs and tables really give us a good way to visually summarize what's going on without having to read every single data point, right? It's visually appealing, it's easy to get your attention, tells the story real fast. You want to be sure to practice, definitely get practice, remember your text, remember your assignment, check your course schedule for when your assignment is due for this section. Remember that in the section, there's practice. At the end, there's practice. And then, of course, your assignment. Remember, if you need help, I'm available. Math Center's available. And there's a ton of resources in Blackboard and in your textbook. So certainly no shortage of resources. Reach out if you need help, and I hope to see you next time. Thanks, and have a great day.